When you think about the future of discovery, you probably imagine, I don't know, a telescope so powerful it can see the first stars being born.
Or a spacecraft maybe that can finally get us to Proxima Centauri.
Exactly. And we usually operate under this one big assumption, right? That all limits are just temporary.
That if you throw enough tech, enough money, enough time at a problem.
You can solve it. But what if that whole idea is just, well, fundamentally wrong?
What if some things are just off limits?
Yeah, what if there are parts of reality, I mean, huge chunks of the cosmos, that we're permanently locked out of?
Yeah.
Not because our engineering failed, but because the rules of existence itself say, nope, you can't go there.
And that is precisely what we're getting into in this deep dive. Our sources, they really challenge that idea that our curiosity can just conquer everything.
Right.
We're exploring what you could call the invisible limits. These are cosmic walls written into the actual laws of physics that prohibit us from ever observing or reaching vast parts of reality forever.
So this isn't about, current setbacks in technology. This is about prohibitions that are built in.
Exactly. Fundamental boundaries.
Okay, so our mission today is to understand these ultimate boundaries.
Right.
We'll start with the more familiar ideas, but really dig into the surprising consequences. Let's just jump in with the biggest scale of all.
The limits of speed and distance.
Which, of course, has to start with the most famous rule in the book.
The cosmic speed limit.
The speed of light. About 300,000 kilometers per second. It's a number that sounds enormous, right?
It is. But in the universe, it's less of a speed and more like an absolute constraint, a hard wall.
And the key thing our sources emphasize is that this isn't a technological failure on our part.
No, not at all. It's not a mechanical limit. It's a relational one. It's woven into the fabric of space-time by Einstein's relativity. You can build the fastest ship imaginable.
And the universe just says no. I think we hear that phrase, nothing can go faster than light.
Yeah.
So often we just kind of nod and forget to ask why.
Yeah, what's the mechanism?
Right. What's actually stopping us from getting that final push?
Well, it really boils down to the relationship between mass and energy. E equals mc squared.
Of course.
As any object with mass, a person, a ship, even a tiny proton, gets closer and closer to the speed of light, its relativistic mass just skyrockets.
It gets heavier.
Exponentially heavier. So to actually reach the speed of light, its mass would have to become infinite.
Which would mean you'd need infinite energy to accelerate it.
Exactly. And the universe, well, it simply doesn't have an infinite amount of energy to give you. The bank is empty.
And that, for you, the listener, has this immediate, really profound consequence. It means because of this one unbreakable rule, huge, real, tangible parts of the cosmos are just permanently off the map.
They're there. They exist.
But we can never touch them. Our max speed draws a line in the sand we can never, ever cross. We're kind of stuck in our own little cosmic neighborhood.
And the really wild part is that our neighborhood is actually shrinking.
Which brings us to the next big wall, the observable universe trap.
This one is a little counterintuitive.
Oh, it's a total mind bender. We all know the universe is 13.8 billion years old. We hear it all the time.
Right. That's the age.
But then you turn on a science documentary and they say the observable universe is 93 billion light years across.
Yeah.
How can something that's only been around for 13.8 billion years have a diameter of 93 billion light years? It feels wrong. It feels like cheating.
It does feel like cheating because our intuition is all about things moving through space. But that's not the whole story.
Okay.
The universe isn't static. The space itself is constantly aggressively expanding. So think of it less like galaxies flying through space and more like the space between the galaxies is stretching, like dots on a balloon being inflated.
So those really distant galaxies aren't just moving away from us. The very fabric of space-time is carrying them away.
Exactly. And here's the crucial point. The most distant bits of space are being carried away from us faster than the speed of light.
Wait. I thought nothing could go faster than light.
Nothing can move through space faster than light. But space itself, it has no speed limit. It can stretch as fast as it wants.
Wow. Okay, so that creates a kind of horizon.
The event horizon of the universe, yes. And for you, listening, the consequence is just, it's dramatic. When we look at the oldest, most distant galaxies we can see, the light from them has been traveling for billions of years, fighting against that expansion.
A marathon runner on a treadmill that's speeding up.
That's a great way to put it. And because the space between us and them is expanding so fast, there's a point of no return. Meaning that right now, as we're having this conversation, there are galaxies we can see in the sky whose future light will never, ever reach us.
So the light they're emitting today is already on the wrong side of that horizon.
Yes. They will eventually just fade away from our view. Not because they exploded or died, but because space itself literally pulled them out of our reach forever. They'll be permanently invisible to any future human civilization.
We're losing entire galaxies from our future sky. That's the ultimate cosmic drama right there, just written into the physics of it all.
It really is. It shows these limits aren't just static rules, they're dynamic processes.
Okay, so let's shift gears. We've talked about the limits of vastness. What about the limits of density, information collapse?
That takes us to maybe the most famous information prison of all. The inside of a black hole.
Right, so we're zooming in from the edge of everything to the most concentrated point of danger imaginable. A black hole isn't just a cosmic vacuum cleaner. It's defined by its boundary.
The event horizon.
The point of no return.
And it's the very specific boundary. It's the spherical region around the singularity where the escape velocity, the speed you need to go to get away, is exactly the speed of light.
So if the escape velocity is the speed of light...
Nothing can escape, not even light itself. It's the most perfect information wall in nature.
Which means once you cross it, you're completely cut off.
Causally disconnected from the rest of the universe. Anything that happens inside a star collapsing, you trying to send a text message is absolutely, totally hidden.
So if no signal, no light, nothing can get out. What does that mean for physics inside? I mean, does time even work the same way in there?
Well, from the outside, we see time warp like crazy near the horizon. But the implication for us as scientists is profound. Inside the event horizon, physics as we know it stops being testable.
Because science is based on observation.
On measurement. And since we can never, ever get any information or measurement out of the interior, we can only describe the black hole by what we see on the outside. Its mass, its charge, and its spin. That's it.
So it's like we could describe the box, but the contents, what the singularity actually is, what happens to the matter that falls in, that is nature's ultimate secret.
Locked away by gravity itself, it's a wall of knowledge we can't breach because the very act of looking is impossible.
A wall against information. Okay, so if that's the wall defined by infinite gravity, let's pivot to the other extreme. A wall defined by infinite smallness.
The Planck scale.
Right. Now we're zooming way, way down, past atoms, past quarks, all the way to the very pixels of reality.
That's a really good analogy, the pixel limit. Think about a digital photo on your screen. If you zoom in far enough, you eventually hit the individual pixels. You can't see any finer detail.
And the Planck length, which is what, 10 to the minus 35 meters? An absurdly small number.
Incredibly small. That's considered the smallest unit of distance that has any sort of meaningful physical reality. Below that level, our understanding of space and time it breaks down.
So what would we see? If we could, hypothetically, build a microscope that could see past that pixel, what's there?
This is where things get really weird, where quantum mechanics and gravity have a massive fight. The scale is so tiny that quantum fluctuations, the little jitters of energy in empty space, become enormous. If you try to pinpoint something, to look at a region smaller than the Planck length,
what happens?
the energy required to do that is so immense you would instantly create a tiny black hole.
You're kidding. So reality has a built-in safety mechanism.
It's like a cosmic error message.
If you try to look too closely, the experiment collapses itself.
It does. And it suggests that below the Planck scale, space and time, they're not the smooth, continuous things we experience. They probably dissolve into a chaotic, probabilistic quantum foam.
A blurry mess.
A bubbling, unstable mess where concepts like here or now just lose all meaning.
So the universe refuses to be fully seen, not just on the grandest scales, but on the tiniest ones too. We can never zoom in far enough to see what reality is really made of.
Because the laws of quantum gravity make the very act of observation physically meaningless at that level. Whether you look out or you look in, you eventually hit a wall.
That is incredible. Okay, so we've covered walls of speed, expansion, information, and scale. That's a lot of walls.
But there are more theoretical ones.
Which takes us to the biggest picture of all, really. Limits of pure access.
Parallel universes.
Right. This is one of the most tantalizing walls because it suggests there isn't just one reality we're locked out of, but maybe an infinite number of them.
Many of the most advanced theories in physics, like M theory and string theory, they strongly suggest that our universe is just one of many.
Bubbles in a much larger cosmic foam.
Exactly. An infinite number of universes existing parallel to ours.
And these other universes, they might have totally different laws of physics, different constants, different histories.
But the wall here is absolute. The defining feature of these parallel worlds, even if they're real, is the total absence of a bridge.
There's no door.
No door, no travel, no communication. The same theories that predict they exist also predict that they are completely causally isolated from us.
So it's not like we just haven't built a fast enough ship yet. It's that the very mechanism for travel, or even sending a signal, just doesn't exist in the architecture of reality.
It is the ultimate case of existence without access. We can theorize about them, but we can never check our work. We can never prove it.
Wow. They're forever beyond our reach, hidden by the very structure of dimensionality.
Or separated by, infinite stretches of nothing we can cross.
Okay, so we've mapped out all these external limits: speed of light, cosmic expansion, black holes, parallel worlds. But this all leads to what might be the toughest wall of all. And the irony is, it's the one closest to us.
The internal wall, the final boundary, isn't out there in the cosmos at all.
It's right here.
In our heads.
The human mind itself might be the final bottleneck. Even if the universe could somehow show us everything, every last secret, our ability to actually understand it might be capped.
This brings up a really important question about our biology. I mean, our brains evolved for a very specific purpose.
To survive.
To survive on the plains of Africa, to find food, manage social groups, dodge predators. They got really, really good at understanding 3 spatial dimensions and time moving in a straight line.
They did not evolve to grasp 11-dimensional spacetime.
Not at all. Or the true weirdness of quantum mechanics, or the kind of hypergeometries that might define the universe. Our whole cognitive toolkit is tailored for survival, not for cosmic truth.
So there could be fundamental aspects of reality that are just beyond our perception, forever.
Not because they're far away, but because our minds literally can't form a concept of them. Our language, our math, the very way our neurons fire, might just be incapable of processing those truths.
It's like trying to explain color to someone who can only think in numbers.
Precisely. A discovery isn't just about what a telescope sees. It's about whether we have the mental capacity to model what it's seeing. And we may have just hit an evolutionary wall.
That is the most humbling limit of all.
It really is. The limits are both cosmic and cognitive.
So let's just try and pull this all together for you.
Yeah.
We started big, with the speed of light and the expansion of space, setting these permanent physical boundaries on where we can go.
Then we dove into the information walls. The absolute blackout inside a black hole's event horizon, and the way reality itself blurs out when you try to look too closely at the Planck scale.
And finally, we looked at the limits of structure, the impossibility of ever reaching other potential universes, and maybe the ultimate limit, the hardware of our own brains.
The big takeaway here is that the universe isn't just mysterious, it's selective. These rules, these prohibitions, they define our reality just as much as the stars we can see and study.
Understanding them is almost more important.
I think so. It encourages you to appreciate the beautiful but finite arena that we get to play in. We're operating strictly within the rules of the game.
And if we can leave you with one final thought to chew on, just consider the sheer scope of this. The volume of what we will never know because of these invisible, unbreakable cosmic walls.
It may be far, far greater than the sum total of everything we ever will know.
Keep exploring those edges.
Even the ones we can't cross.
That's all for this deep dive. We'll see you next time.